Thank you for your introduction. Hello everyone, I'm Liang Shang, a student from Kyushu University. Today I will introduce my work titled Localized Surface Plasmon Resonance Modified with Molecularly Imprinted Social Sensory for Plant Volatile Organic Compounds Detection. Firstly, introduction. Plant volatile organic compounds is very important and they always release from flowers, leaves, and roots. They play several important roles for plants, such as to attack the pollinators and plants self-protection. And these POVCs can not only act as wound sealers, but also as a but also to attract the predators. PVOC always plays a very important signal for plant-plant communication. So we can regard PVOCs as the language for plants. It is very important to detect the PVOCs for pest detection, plant monitoring, for agriculture activity. So we need a translator for these plants. But the traditional methods such as GCMS can finish that work, but is not suitable for PVOC's real-time monitoring because of its high cost, not portable, and time-consuming. So we need some sensors to detect the PVOCs with high speed, low cost, and high sensitivity. In this study, I will talk about these four important type of PVOCs. And this, I will, my sensor is LSPR sensors, and in the mechanism of LSPR sensor was shown in this slide. We can know that by this formula, we can know that the absorption spectrum depended on the particle size, shape, composition, and the surrounding media. So this method could be applied in developing chemical sensors and balance. The advantage of LSPR sensors are faster response and recovery speed, but LSPR sensors are not specificity sensors. To overcome that problem, molecular imprinting software was uh, used in this study. Whether unusual cavities generated uh, by templates, the target vapor would be absorbed selectively. MISG is one type of molecular imprint polymer. The advantages of MISG is stability of chemical and thermal. So this uh, MISG is more suitable for LSPR sensors. The concept of the MISG LSPR sensor was shown in this slide. And the MISG layer was selected as a selective absorption layer, and the AU nanoparticles layer was as a LSPR sensing layer. And by detecting the change of spectra, the target PVOC vapor would be selective detected. And here we restarted AU nanoparticles on the of MRC to increase the response. Because PVOC is always comprised by many different type of compounds. Here we established a few LSPR sensor array to finish. The experiment was shown in this slide, and for MRIG material fabrication, we mix these chemicals together and heat it in a 60 centigrade water bath for 1 hour. After that, AU nanoparticles were spurted on the surface of glass substrate and annealed at 500 centigrade, and the MRSG reaction solution was coated on the surface of AU nanoparticles and annealed at 130 centigrade for removing the templates. Finally, AU nanoparticles was resparted on the surface of MRSG and annealed at 130 centigrade. This slide shows the testing system. The vapor generation system was include an air pump, a filter, two mass flow controllers, a DAQ card, a computer, and a gas wave. And by controlling these two mass flow controllers, the concentration of gas would be controlled. And the LSPR spectral testing system was include a spectrometer, a computer, a gas room, some optical fibers, and a light source. the spectra would be recorded and detected by this system. Then we talk about the result. The absorption, the spectra shows that the soil layer made the plasmon peak shift to the right, and the A max was increased, and the lambda max was shifted to the right with the increasing of thickness of recording AU nanoparticles. And through the EM images, we can find that the layer by layer films was constructed on the substrate successfully, and the size of AU nanoparticles islands on MISG layer was dependent on the thickness of recording AU nanoparticles. And this slide shows the selectivity of layer-by-layer sensors. Through this filter, we can find that with different thickness of AU nanoparticles, the selectivity and the sensitivity are different. And the sensitivities of MISG AU nanoparticles are higher than MISG only. It can be explained by the hot spots between the bottom and the surface AU nanoparticles. And two large AU nanoparticles, AU islands, would induce a worse selectivity for LSPR sensors. And this slide shows the real-time response of a layer-by-layer sensors to four different types of PVOCs. Through this filter, we can find that a specific selectivity to Cis-Jasmone vapors was obtained, and the limit of detection was calculated at 3.45 ppm. And this slide shows the MISG LSPR sensor array fabrication. And by changing the template in MISG solution, and we can get different type of MISG solution. And by coding them, we can get different channels. And in this study, we have 5 channels. One is bare, and other 4 types of PVOCs have 4 channels. And after that, by controlling the flow rate, we can get different concentrations of gas, and all the response rate metrics was scaled and for more processing. And this is the PCA result and LADA result for PVOC sensor array. And through this PVOC space, we can find that overlap was observed in all PCA spaces. In PC1, PC2 space, we can find that a low overlap between Cis-Jasmone and alpha penny. But in PC1, PC3 space, we can find Cis-Jasmone have a independent array. And we can also find in PC2, PC3 space, alpha penny have an independent array. But in LDA space, an acceptable discriminant result was observed. Based on leave one out cross-validation method, the accuracy of LDA model was calculated as 94%. And the result indicated that MISG LSPR sensor array would be applied in PVOC discrimination. Finally, conclusion. A layer-by-layer film was developed for the determination of PVOC selectivity, and a combination of soil technology and AU nanoparticles. Hotspots were constructed for enhancing the sensitivity of MISG-coded LSPR sensors. And the real-time response was verified to be fast, selective, and reversible. The limit of detection for Cis-Jasmone was calculated at 3.45 ppm, and we based it on the MISG LSPR sensor array and the LDA models. PVOCs can be discriminated. Thank you for your attention.